I left for you to Pradium. There are two different parts, one in the circular economy, one in the life cycle with much more details, but I don't have enough time to take each one. It will be very long, and I use one of my past presentations that combines both, okay? The idea here is to give you more insight about those problematics for circular economy and also for life cycle assessment, and not go really in depth. But if you want to learn more, my slides, they have much more things inside, okay? The slides that we'll get. Okay, well, let's speak to a more condensed way. This is the reason that I changed it. I didn't use the initial slides. You have the full slides in the aside, you will get it. But this one is a condensed version speaking about lighting, circular economy, and life cycle assessment. Let's start with fundamentals. This is always the case. What is the circular economy? This is the first thing. Well, circular economy aims to redefine growth, focusing on positive society-wide effects. Well, the idea here is always to create financial growth, but at that time we have to take into account what are the needs of the society. Looking beyond, our past model is that we call the linear economy model that inherently considers that resources are infinity. That means what? We use resources, we produce products, we use the products, and as the products are no more operational, we waste them. And that's all. And of course, this model will fail if we are not able to provide enough resources here. Circular economy is a little bit different because gradually decouple the activity of the consumption and the resources. And the idea is to build that in three principles: eliminate waste and pollution, circulate products and materials that they have the highest value, and regenerate nature. In fact, you take that, you close it, you use raw materials, you make products, you use the products, at the end of the life of the products, you recover either the product you repair or you recover part of the materials, of the components, and you reuse, or at least you are able to get back the raw materials and start the cycle again. In that case, you decouple the product production and use from the raw material resources. In fact, you have this graphics that is this plot that is very often used to explain what is circular economy. We call that the butterfly diagram. And here, in fact, you have two main cycles. The first one is the technological cycle. Is the cycle raw materials, products, use, and how to keep them in circulation as long as possible. And on the other side, you have the biological one. What happens? It's time that you extract materials, you use products, and you recycle products. How that impact the biological cycle of our ecosystem, starting from nutrient materials or biodegradable materials that have to be returned to the earth and generate the ecosystem. The linear economy model completely forget this part. But the linear economy has been built during the first industrial revolution, beginning of 19th century, while the revolution was mid of 18th century. The model built from 19th century, no more valid. Because today we know that we don't have enough raw earths, we don't have enough energy, we don't have enough water. And each time that we use that kind of resources, we can penalize other activities. I will give you an example. You heard, all of you, about gasoline and things like that made from crops. Okay, when we started to think about that with the linear economy model, is how we can produce biogasoline for our cars, and for that we can use, for example, corn. Okay, and what happened in Mexico? As biogasoline was more expensive, and people could sell their corn production for biogasoline, all the corn production of Mexico during some years have been dedicated to biogasoline. Result: Mexicans, citizens, they pay their tortillas, their naan if you want, more and more expensive, because as the request for corn flour was much higher than the production, the price increased. And then they understood, yeah, okay, we have to produce gasoline, but we need also to produce enough corn in order to be able to produce bread, tortillas. Today there are two big concepts that we are trying to implement everywhere in our economy. One is the circular economy, and the other, which is a little bit older, is the sustainability. Those two concepts, they are not the same. As you can see here, the sustainable development is a development that meets the needs of present without compromising the ability of future generations to meet their own needs. Okay? Circular economy is a system solution framework that tackles global challenges like climate change, biodiversity loss, waste, and production. They target two different things. Sustainable development implies a wider approach than a simple economic growth, and includes indicators about social and environmental impacts, which is not the case here. Circular economy implies to get into a system able to regenerate by itself and save then primary resources. And finally, circular economy doesn't implies automatically sustainability. They are two different things. Circular economy is based on the idea I told you from the beginning, how we can reduce wastes and reduce also our dependence from primary resources and raw materials. There are several levels in that we call the waste management, from the last preferred up to most preferred. The first one, which is that usually we have in our countries, maybe a little bit more here in India than in some other countries, is dispose. You throw, that's all. Then the second level is you still stay at waste level, but you treat. Instead to throw everywhere, someone collects, you burn, you bury, I don't know what, you find different ways to eliminate the wastes. The level above is recover. Recover what? recover materials, recover operating parts. If you take a mobile phone which is still operational because you buy a new one, you can recover a lot of parts inside. You can recover also some raw materials or expensive materials like gold. And of course, even if you burn your wastes, you can recover energy. For example, there is a district in my city, in Toulouse, that all the wastes, the non-recyclable wastes, they are incinerated, and they use the incinerator to produce hot water for heating the buildings of the district. Then, still in waste here, you have recycle. That means before destroy your device, maybe you can use it somehow, recycle. And you pass here now from waste status to product status. How you can reuse something old that is initially considered as waste. Here is mainly repair. The problem is, depends on which country you are living. If you go to Occidental Western countries, the problem is that manpower costs a lot of money. And repairing something sometimes need a lot of manpower. That means if I repair, is economically speaking less interesting that I throw and I buy something new. Now if you go to countries with manpower is less expensive, then the model of repairing becomes much more interesting. And then you are here from wastes, you pass to new products, and then if you go a little bit higher, the first objective is how you can reduce the consumption because you don't need it. This is avoid the famous Zevon's paradox. And how also you can avoid. Why create new needs if you don't need it really? Okay? This becomes in more philosophic level. I'm fully agreeing, say up to here. Here is something that we have really to think about. For example, some extremist people can say, oh, why you are traveling so often? You are authorized to take the plane only 2 times per year, only 1 time per year. This is limiting my liberty, and I'm not ready to go up to there. I can negotiate, but not any kind of thing imposed. Recycling versus reusing, this can be appears different. Recycling enables to reduce the demand of raw materials, demands less energy than the production of primary materials. If I need, for example, raw earths to create new batteries for energy storage, I have to spend huge quantity of energy in order to extract the raw material, if there is enough, refine the raw material, and then use it. The idea here is if I can get it back from wastes, this shall be less expensive to the energy point of view than extracting the material. The problem is I can be winner to the energy side, but economically speaking, I may be loser, because if the extraction process is very complicated, if it is less energy demanding, could be very expensive, and then it's better to continue with the primary material extraction, unless if I don't have enough. And in any case, if I don't have enough materials, the price of the material will increase. This economy rules, and it is clear that from above a quantity of needed material, recycling will be, economically speaking, much more interesting than extracting. Reusing means reduce the demand from primary raw materials that by making products more durable or easier to repair from the design stage, or remanufacturing process in order to do that. Well, that means what? If I take that, I cannot dismount it. I cannot go to the battery. I cannot access the different components. That means when my battery will be off, most probably a few months from now, I have it for 2.5 years. Even if I want to change the battery, I cannot do it. I have to buy a new one. I have to think how I'm able to change the battery here. But you have to understand also why I cannot change the battery. It's not only because Apple wants to sell more iPhones. This is also okay. This is a reason. But also Apple will defend themselves by telling, if you open the device, you lost the guarantee. And if you put a bad quality battery, you will be dissatisfied, and also you can damage the device. And they tell you, you pay for the recycling, send it to us, and we know how to take the parts off and recycle it. Okay, and what they do for that, I don't know if it is valid here or not. When I go in France, when I will change my telephone, they may get it back for 50 euros. They will cut 50 euros from the new one because I bring back the old, and avoids me to keep it somewhere at home or put it on the basket. Here means that we need to create productive maintenance solutions and also develop second-hand markets. And to be honest, in countries like India, this is much more developed than in Western countries. We have very bad habits in Western countries. We want to have new products always, and we forget these second-hand markets. European Union, has recycling targets for packaging. We want to be able to recycle at least 70% of packaging by 2030, and this is also something completely stupid. This is a packaging. Sometimes when you open the package, you have that inside. You have to think about, is logic or not? They told you yes, is to protect what is inside. Okay? And sometimes also the real answer is that my machine knows to make packaging for any kind of products, and they adapt the big packaging to the smaller products because I use the same packaging for the larger products. And also, we want to reduce municipal waste by 65% by 2035. Very nice idea, but when you see how we apply that in France, you become crazy. Each city council has different rules for recycling. They have different rules for collecting. Some cities, they told you, you can put on the municipal trash 2 times per week. If you go higher, you have to pay. And what happened? The people from the village that you have to pay because you have more wastes than they ask you, they go to the nearby village that they don't have any constraint of that, and they would put all the waste there. You just move the problems. And well, this is all the absurd situation if we don't standardize, once again, problem of standardization, this kind of actions. And of course, in Europe, you have this kind of logos that they show that what you bought is recycled or not. I don't know, maybe in this box you may have one that shows that the been recycled or not. Reduce. this is the second, the higher step. Reduce demand of a product that is linked to the thinking, the concept of ownership. This concept is pushing more to a loan, lease than own. Today we are trying to developing more and more lease systems for cars. Instead to buy your car, you take a new car and you pay the car for a number of years. This is the lease, and if you want to keep the car, you have to buy an additional amount of money, or you can change your car and continue leasing. How this can apply in lighting? We can pass that we call to lighting as a service. Instead to buy this lighting system, especially when the lighting system will be very complex with sensors, with all that stuff, that means a lot of maintenance, is still to buy and own it. Me, manufacturer of the system, I can rent to you, ask you to pay an amount of money per month for the lease, and additionally you pay for the light that you produce. This has some good effects. If you pay for the lease, you don't have to pay all the money from the beginning. And if the system is leased, me as manufacturer, I am the owner and I have to guarantee that my system is operating correctly at any moment. That means I ensure the maintenance. Okay? On the other hand, if you pay for the product, the light, you will take more care about the use of the light, and you will push to implement energy efficient activities. This is fine. Up to here is okay, but if the system is now gateway for data, the system is not belonging to you. To who belongs the data? They can show you that when you have that, you can save up to 70% of cash expenses yearly. This is very attractive, but what are the conditions behind? Lease a car is a good idea, but you know very well, when you return the car, if there is a scratch in the painting, they will tell you, there is a scratch there, you have to pay for the repair, and they tell you, okay, repair the scratch, more. That you will pay for the next one, and things like that. And you have to be very careful with all the rules, and here you need to have good knowledge about legal things, what legally is doable, what is not doable, and what they can impose you or not. Avoid, as I told you, can be very can be very compulsory and not pleasant way to avoid things. We can forbid. Okay, we forbidden the incandescent lamps. We forbidden the fluorescent lamps now. Why? Because we know that with those systems we needed to spend huge amount of money to make incentives, and we know that if we do that, if we spend that amount of money, will increase the global efficiency of the lighting park by a few percent, which is no more valid. But if we switch completely to much more efficient technologies, then we are always winner, and in that case we decide to forbid. Now, if they forbid me to take the aircraft as many times as I want, it's against my freedom, but it's also very impacting, for example, to aviation companies. And that is impacting tourism, that is impacting the global economy, and it's very difficult to take such kind of decision. Another way to avoid is just to conceiving a system to a modular way. You buy the fundamental system and then you add options. But to do that, you need to standardize all the system and especially the interface in order to add options. This is the objective of ZAGA consortium in lighting, that they produce standards. For example, you buy this lighting pole for street lighting without sensors, but you have here a plug which is standardized by ZAGA. Also the dimension of the is standardized, and then if tomorrow you want to add some sensors, you can buy ZAGA compatible sensors, you plug it, and then the remaining part is just a problem of software. Or, for example, here you can imagine that the driver, you can open the fixture, get out the driver, you put a new driver with the standards, ZAGA standards, could be from any manufacturer, could be with different things, but you can keep your device operational longer and you avoid to buy new stuff. Because if the LEDs here, they have 50,000 hours of lifespan, 50,000 hours in a city is 10 years of operation, even more, but the driver will collapse maybe in half time. Then if you change just the driver, you avoid to buy a new fixture. Okay, let's take a half hour, that will be enough. How we can evaluate the impact? I told you today, and from the beginning of the week, energy. We consume 13.7% of electricity to light up, and what will happen in the next years. But the electricity, I spoke to you all about 1,150,000,000 metric tons of CO2. Yes, thank you. But energy consumption and CO2 is not only the only two factors that they determine the impact in the environment. You understood very well that raw earths or anything raw materials can also have an impact to our environment. Just speaking about energy and carbon footprint is just a partial answer to the question. To do that, you need to develop new concepts or use existing concepts. And the best one for that is using the life cycle assessment. There is the fundamentals of the life cycle assessment. Life cycle assessment is primarily a method to measure the environmental impacts of various economic activities, not only products, can apply to anything, throughout the life cycle of the product or process. That means you go from cradle to grave, from the extraction of the materials to end of life treatment. LCA can identify the points on which the product can be improved and designed to prevent impacts. And LCA, in principle, doesn't include any economic aspects. It's independent of how much it will cost, but LCA can give you indication where to play in order to reduce the impacts. And you can see it here. You start with inputs in your system, your cradle, energy, materials, water, use of land. When you build a factory, a super factory for batteries, you transform ground from its primary objective, which is to produce food for people, agriculture, you transform it to a factory. You have to take into account this also here. Then you have the conception phase, which is outside. Then you have the production and the packaging of the product from the factory. From the production, you have to bring the product. For example, LEDs today we produce mainly in China. We have to bring them to US, to Europe, to India. And for that we will use lorries, cargo boats, and things like that. And then once you arrive in the main ports of each country, you have to distribute inside the country, again with lorries. And then you install and you use it. And when you use it, it's a if it is an electrical appliance, you consume energy, and the energy that you consume has been produced by renewables, radioactivity, gas, petrol, or I don't know what other waterfalls. Okay, and finally, what is doing the end of life? You can collect, but if you collect, you need to transport again, and then you need to treat. And if you treat, some you can repair and you can send it here. Then you can improve, you can recover components, operational, and send them there. You can also recover materials and send it here. And you can also recover energy by burning the remaining. And of course, at the end, the objective is to reduce that one, wastes, any kind of wastes, solid, liquid, gaseous, heat, or toxic wastes, or radioactive wastes that you may have and you need to store. And the blue and the red arrows is inward and outward fluxes of energy, materials, and water. LCA is a standardized process. It's standardized by ISO 14040 and ISO 14044 standards. Those standards, they are free. You can get it with the guides how to make the LCA, and they are softwares, freeware softwares for making LCA. And then you have also more advanced softwares that they have access to some database. We speak about that you don't pay the software, but you pay the access to the database. Okay, well, how you make this life cycle assessment? The standard defines several things. First, defines that we call the frontiers of the system. When you want to study what is the impact of that, do you take into account only that, or you want also to take into account the factory behind and things like that? You have to define what are the frontiers from where to where you make your LCA. And be careful to not make several times the same thing, and that will become equals 1 + 1 = 3. You can count twice the same thing. Okay? You have then to define, we speak about that, the system boundaries, the functional unit. And the first thing to do, the first step, is to define what is your goal and what is the scope definition. What you want to study, that, and for whom? For the consumer, for the government, for the industry. This is very important from the beginning because will guide what you have to take into account and how present your results. Second, when you have that, you have to define your data inventory. What materials are here? How much plastic? You can dismount and weight the plastic. Look how many resistors, how many capacitors, how many PN junctions are in. And even you can go to very low level, but it becomes difficult. But even you have to know what kind of plastic material is that. This is a little bit complex. Then, when you finish that, you need to evaluate the impacts. And to do that, you need to pass through 3 steps: classification, characterization, and weighting. You take the different impacts in order to get answers. I will show you that how it works. And the 4th step is the interpretation and the evaluation of potential improvements. The presentation of the result here and the interpretation is very subjective. It depends who is your target. And unfortunately, the interpretation here has nothing to real scientific behind. You can cheat very easily. And this is problematic. The standard assumes that the person who is doing the LCA is a perfect person and never cheats. This is also a very good principle in some economical models, but we know very well that they are not working. And finally, 5th step, but this is outside of the ISO is how you can use the result here in order to make market interventions for governments or for factories, for industry people, or for retailers also. Let's go step by step. The first thing is to define what you include in your life cycle assessment. I will give you an example. You understood that I'm flying a lot. I like aircrafts, and Air France love me. Okay, and then I arrive here. I spend, of course, for that, the aircraft spend a number of kerosene and CO2 injected in the atmosphere. Then, if I want to calculate what is my impact for that, I have to say what I'm taking into account. If I take only the aircraft without me, the aircraft flying from Toulouse to Delhi, forget the immediately, every day. Why is my problem? I'm cheating here, okay? Because if many people like me travel a lot, you have more planes flying, okay? This is the point. But if I define the frontier only the aircraft, it's not my problem. Second option is I say the aircraft plus George, okay? That means George is responsible for 1/300 persons of how much CO2 the aircraft rejected to the atmosphere only the day that I flown from Paris to Delhi. Okay? This is good. This is no cheating. But third option, which is much more logical, is why George took the plane and what George's action involved to this trip can save energy. I teach you about efficient lighting. If you apply 1% of what I teach you here, maybe you will make significant energy economies, and then I can say, you made that because you are aware of the problem thanks to my teaching, and then I can have some positive part that I have to include and reduce my impact. In mid of 2000, I work as a chief officer for a UNDP program, United Nations, and I help Russian Federation because the known problem, before the known problems with Uncle Putin, today to develop the sustainable lighting program of the Russian Federation. I know that Russian Federation is applying that program today that I built, and they save billions of CO2 per year. If I take into account that and to include it to my carbon footprint, I am positive as many travels I do, and I will be positive till to the third generation of my kids. Okay? Well, you see three different frontiers, three different interpretations. Which one is the most honest than the other? This is a very good question. It depends who I will address each time and what are the objectives of my work. Step second, define the functional unit. You learn from the primary school that you cannot add pears and apples. Okay? Yes, but if you say that pears and apples, they are fruits, if I have 3 pears and 2 apples, I have 5 fruits. Because I define a new functional unit, which is not more pears and apples, is fruits. Okay? Of course, I cannot add now cows, unless if I say both they are living stuff, and then I can do it well. That means I have to define what is the functional unit, and to define that functional unit is very important in order to compare comparable things. I cannot compare an incandescent lamp to a compact fluorescent lamp or to a single LED lamp. If I do that, the incandescent lamp is frankly the winner, because they have very few materials inside, very few energy is used to produce the lamp, and if you go to LEDs, then one LED lamp compared to one incandescent lamp is a catastrophe. But one LED lamp produces very low lumens for 1,000 hours. LEDs will produce a lot of lumens for 50,000 hours. That means, I will show you that just after, to get the same quantity of light produced by a single LED lamp, you may need 30 incandescent lamps, and then you have to compare 30 incandescent lamps with one LED lamp. I will show you that after. Life cycle inventory, this is the second step. Here is what is there. It's plastic, it's components, it's glass, it's, well, where you stop? You stop just to the plastic. You say this one has 10 grams of plastic, 1 gram of glass, 3 resistors and 5 capacitors, 5 FETs, or you go beyond. You don't need to go beyond, because there are international database that tell you for this plastic, 1 gram of plastic has been produced by a given manufacturer, and this given manufacturer can tell you how much impact on different parameters you have when you produce 1 gram of that plastic. Then you have to have access and be able to collect all those data. The problem is, as you will see those data, they are very sensitive. If the manufacturer of that say you how produce this plastic, or from whom bought that plastic, and this one told you how produce the plastic, have to tell you also where he found the initial materials, and that means they have to open all their approvisionment line. You have to understand who sell to whom what, how has been extracted, and if you make that publicly available, no people from industry will accept something like that. We try then to have international databases that they have average values, that they are not sensitive. You know, if you have hard plastic, you have this kind of impacts, plus or minus something, okay? You never have the exact thing. And those one, they are LCA Federal Commons in US and EcoInvent database in Europe. Those databases include huge information. If you take an ohmic resistor and you go to here, it tells you what materials are behind and how this resistor is produced, and you can make all your calculation there. Then, once you get your results, well, normally you get results for different things, standardized, exposure, noise, air quality, impacts and things like that. And then you have here a number of parameters. They coming out from the software. And you will have a bunch of parameters. Then you have to combine those parameters in order to, for example, here, using some weighting methods, to say, okay, we look what is the impact in mortality, what is the damage to animals and plant, loss of biodiversity, and things like that. You have standardized methods to do that. But if you give all those things, if you give all that, no one will read it. If you give that, some specialized people may be interested. Then you can say, just I want to see what are the impacts of the process or the products to human health, to ecosystem quantity, to natural resources, and life supporting functions. This is only 5 indicators, but they include all that behind. And how you get from there and there to there, you have to use some weighting methods. And finally, governments will tell you is this one more impacting than that? And they don't want to see 5 or 10, they don't want to see, but they want one figure. And then you can compact that with other methods to a single figure, which is the environmental impact index. Example, domestic lighting. There is the scope of the system and the boundaries. You need to include all that. Manufacturing, transport, use, end of life. Inside you have different parts for the manufacturing. You need to take into account the raw materials, the equipment used for the manufacturing, the water input, the surface that you are used to produce, the surface of the factories to produce the material, and of course the energy everywhere in all the process. It happens that, and this is true mainly for any kind of energy using appliance, the raw materials and consumption transformation here is less than 4% of the global impact. That means you can discard it because in any case all the data that you'll have, they are with a plus or minus 10% uncertainty. Well, if you forget that one, it's not very important. The end of life also is neglectable. But if you forget both, then it becomes to be problematic. But in fact, transport is very teeny. Usually we consider very roughly. And if you make the sum here, that you see that use phase is the most important. 80% of any electrical appliance, 80% of impact is during the period that you use the appliance and you consume electricity behind. That means you can reduce the life cycle only in that phase, but sometimes it's not a good idea. And there is what I was telling, the definition of functional unit. To get 20 million lumen hours that you will produce with a 9 watt LED lamp producing 855 lumens operating for 25,000 hours, you will need 3 CFLs of 30 watt, 845 lumens, very similar, living for 8,000 hours, and you will need 15 incandescent lamps, 75 watt, 900 lumens, with 1,500 hours lifespan. That means you compare one of those with 15 here and 13 there. The result is the same quantity of light at the end, usable light. And there is the result. There is the result for the different phases. You see that in all cases, use is the more impacting, but you can see here for LEDs, materials start to be not so more neglectable to the others. There is the impact quantification in climate change, use of natural resources, ozone depletion, photochemical pollution of our atmosphere, and eutrophication. This is the pollution of the water, okay? And you can see, if you take now 15 GLS lamp, incandescent lamp, 3 CFLs, and 1 LED lamp, here the global impact merit point, this is the worst, this is the second, but still comparable, and LED seems to be the best. But that goes for old LED technology with less than 100 lumen per watt luminous efficacy. Today we go up to 200 lumen per watt. That means this figure here is maybe divided by 2. Today LEDs, they are much more interesting than any other resource, and you can see here again, incandescent is the more impacting, CFLs is the blue one, and LEDs is the gray one. In some of the criteria, LEDs and CFL, with that LED technology, they are comparable. Beginning of 2010, 2015, it was very difficult to say that LEDs are less impacting than CFLs. Today is absolutely the inverse. And here you see that was combined effects or a single indicator. And this is, for example, now the effects for LEDs in all the criteria. 16 criteria proposed by ISO standard. And this is, you can see here the effect of the different parts of the system, the PCB, the packaging, the transport, the production, the phosphors inside, the heat sink, and the drivers. And in fact, when you look at that, the heat sink and the driver, they are the more impacting parts for the production side. Lifespan also is very interesting because if you have lamps with 36,000 hours lifespan, they are much more impacting than if you have the same lamps with 50,000 hours, because if you want to keep the same quantity of light, here you avoid all the light green things, which is linked to the fact that you will change at least one time your lamp in order to achieve the same quantity of light. Here is just relamping effect. The place also where the lamps are used is very important. Remind you that 80, 70 maybe percent or 80% of the impact is the electricity use. And the electricity use produced in India is not produced the same way in France or in Germany or in US or in New Zealand. And you can see here the same lamp produced in China, I'm speaking about LED or CFLs or what other, used in France, in Poland, in Norway. France, 50%, 70% of our energy is nuclear, no CO2, but produces radioactivity. In Poland, almost 80%, 85% is petrol and coal. And Norway, more than 50% of the energy production is hydroelectric, which is no CO2, no radioactivity. And you can see here now the same lamps. Of course, always incandescent is more impacting, but LED is clearly less impacting in Norway than in France. And even it's 5 times more impacting in Poland than in France, or in the same lamp for the same use. And here you see also the different phases. And you see when we go to Norway with very clean green electricity, real green electricity, well, the material consumption is more impacting than the end use. That means if you make your LCA and you say, I don't care about the materials, your result is absolutely wrong for Norway situations or any kind of countries with very green energy. And this is almost the last one. LCA and life system, well, all what I show you here, you can obtain by using simple calculations, by using softwares, but you need to have the right data, you need to make the right analysis, and most of all, you have to be honest in the interpretation that you provide to your client. Okay, you have a client, you have to give an interpretation, you have to be honest. If you have any bias in your way of interpreting the results, that can be very damaging. It's difficult to conclude for different lamps, but it is clear that today incandescence is the baddest one. We put it out. Fluorescence seems to be not very good, and this is confirmed with new cases in the real slides that I didn't use today. and I left to Pradium, you can see much more examples with more modern LED lamps, and of course here you can use that. But something that is limiting here is that the global performance depends on lifetime and efficacy couple, and this is, can vary from one manufacturer to the other, can vary from the way that you use the lamp, can vary from the quality of the electrical grid that you are using to supply the lamp. There is a lack of information on end-of-life disposal and recycling. In France, I can find that information. I don't think that I will find that in India, or maybe it will be very incomplete. And finally, ISO standard method doesn't take into account impacts on the well-being and the performance. Takes impacts on cancer or toxic materials that is harmful for life itself, but doesn't take into account light pollution, doesn't take into account well-being, all what we suggest before, and that means even this kind of things, they have to be reconsidered and they have to be taken into account. I go rapidly here. You have to include in a standard LCA, you have to include some economic aspects and also some social aspects, and then passing from standard LCA to a societal life cycle assessment. And this is, that was for when I made this presentation, I had available a PhD fellowship on that subject, and it was just to make publicity. While the guy in my team and finished his PhD this year. Well, I don't have any more this fellowship available. Yes, that everything that I was to tell you about how to identify LCA effects and take into account the global impact of lighting systems. All that you can apply to any kind of system, not only lighting system or services also. Okay, but you have to be very careful how to use it. Okay, thank you. Well, this is the critical time. I propose here a small evaluation. Yes, you can give. I consider that 40 minutes is more than enough to answer. Don't worry. Well, you don't have any danger to lose something if you don't understand a question. Try to respond. Some simple calculations are there. Normally the formulas they are given. Try, and I will correct it. And I will send a scan to Pradium, and then Pradium can give it back to you. I will not correct it today, and you can see what are the errors that you made. Well, you are sit very close one to the other. As I tell to my students, don't copy for different. No, it's okay, Pradium. Like life cycle assessment, here is learning cycle assessment for you. If you have questions, ask. For the first question, you have the potential answers there. You have to choose the right one.